Hello everyone, welcome to Techno Herald Online. Today we are going to start lesson 3. In lesson 3 we will study about the differential length, differential surface and the differential volume. Then we will study about the line integral, surface integral and the volume integral. Till now we have discussed about the basic concepts in the vector calculus. We have seen the Cartesian coordinates, cylindrical coordinates and the spherical coordinates. Now we are entering into the new chapter which is also under the vector calculus, but here we will study about the differentiation and the integration of the vectors. The differentiation and the integration of the vectors are very important for studying the other concepts of the electromagnetics. So we will deal these concepts here. So before going into the deep into the differentiation and the integration of the vectors, first we will study about the differential length. What do you mean to say by the differential length? What do you mean to say by the differential area and the differential volume? So let's start with the first topic, that is differential length differential area, and the third one, differential volume. Okay. What do you mean to say by the differential? Differential means to say a very small element. So we have already seen in the case of the integration, when we integrate something, what we do? Suppose that this is any curve and this is a point A, initial point A, and this is the final point B. When somebody asks you to just integrate over this curve, then what do? We just take a small element dx and we integrate it, that integration dx from A to B. Okay, this is what we do in the case of the integration. So what we have taken a very small element here, okay, very small element, and we have integrated this small element throughout, that is from A to the point A to the point B. So this element, this very small element, is nothing but the differential. Differential means very small element. Okay, that is what we mean to say by the differential. So in case of the vector calculus, first we need to define it in a suitable manner. It is not so easy like we have taken a dx and we have integrated like this. Here in the vector calculus, we need to define this every term separately, and we need to look at that which quantity is a scalar or which quantity is a vector, and accordingly we just perform the integration and the differentiation. If it is a vector, it will have some direction. If it is a scalar, then it's all right. So let's define what is differential length first. So first, what is differential length? Differential length. So let's draw the axis first in Cartesian coordinates. X axis, Y axis and Z axis. All the three axes are mutually perpendicular to each other. Let's take a small cube here. Okay, this is a small cube that I have taken in space. Let's name it. Let it be this be A, B, C, D. This point be P, Q, R, S. Okay. So this is a small cube I have taken in space. So let the coordinate of the point S be X, Y, Z, and let the coordinate of the point B be X plus dx, Y plus dy, or Z plus dz. Okay, let's again write this here. The coordinates of the S are X, Y, Z, and coordinates of the point B X plus dx, okay, Y plus dy, Z plus dz. Then what does it mean? If we move from point S to the point B, then there is a differential increase in the x-axis, x variable. There is a differential increase of the dy in the y-axis, and there is a differential increase of dz in the z-axis. Initially, it was x, it was y, and it was z. When we have increased a very small quantity, when we have in the length of x, y, z, where we have reached the point P.